Hi everyone, welcome to my YouTube channel. Today we'll be solving the question reverse linked list. So in this question we're given the head of a singly linked list and we have to reverse the list and return the reversed list. So in this problem we have a linked list 1 pointing to 2, 2 pointing to 3, 3 pointing to 4 and 4 pointing to 5. And in the end we have to return a reverse linked list. So we need to point 5 to 4, 4 to 3, 3 to 2, and 2 will point to 1. So basically, the initial head is at 1, and the final reverse linked list, the head will be at 5. So this is the new head. So yeah, let's dive in to the approaches with which we can solve this problem. So we can solve this problem using. So I'll be covering three approaches to solve this problem. So in the first approach, what we'll be looking into is uh, not we won't be dealing with null pointers. So this first approach is so when I solved this problem for the first time, I used this approach because I was afraid of using null pointers, and basically I was afraid of dealing with null pointer exceptions. So we can have a look at this approach, and we can have a look at better approaches after we cover this one. So in this approach, what we're going to do is we have the linked list 1, 2, 3, 4, 5. So initially the head is at 1, and so to reverse this linked list, we are going to need to traverse this linked list. So let's say the linked list size is n, and to traverse this linked list, it will take us O of n operations. And how do we traverse this linked list? We are going to use a current pointer, and once we like process the first element, we're going to move on to the next element, and one by one till we reach the null node, we are done processing the whole linked list. And while we are processing this linked list, we are going to reverse it. And how do we reverse it? So initially we have the current pointer, and we will make use of a next pointer which will point to current dot next. And as we are iterating over the linked list, we are going to mark the next pointer of the next node to point to the current node, and this will update this pointer, and it's gonna point to 1. And while we update the next pointer of this node 2, we're going to lose the reference to node 3. So to avoid losing that reference, we're going to use another variable temp, so that we don't lose the reference to the node 3. And as we are iterating over the linked list, we mark next dot next equal to current, and once we are done with this, we move on to the next iteration. And in the next iteration, what we're going to do is we're going to update this current pointer to point to the next node, and the next pointer becomes our temp node, and the temp will become the node 4. And now you might be wondering, like, we did not update the reference to the node 1 here. the node 1 here. So for that, what we are going to do is we're going to check if current equal to head. Then we can do current dot next equal to null, and we this will only be for the head node, because once we are like let me draw another example. So now 2 points to 1, now we have 3, 4, 5, and now the current is 2, next is 3, temp is 4, and 1 points to null because we added an if check. So we only need to do this if check for the head node, because in the next iteration we can just update this node 3 to point to node 2, and we won't need to update this node 2 because we already updated this node 2 in the previous iteration. So we only need this if block for the head node, and once we reach the end of the linked list, now how to identify we reach the end of the linked list. So at the end, what we're gonna have is we're gonna have a situation where our node 5 is current node and our next node is null. So we only keep on going. So we're gonna have a while loop to iterate over the linked list, and we're gonna have a condition while next is not equal to null, and once our next node is null, we will stop processing, and at the end we are gonna return, once we are done with the while loop, we can return the current node. All right, so good. So this approach only works for a linked list which has greater than equal to 2 elements. So why we did this? Because we did not want to deal with null pointers directly, and the base case would be when head is null and head dot next is null. So in that case, we just gonna return the head of the linked list. All right, let's dive into the coding implementation of our first approach. So yeah, we given this function reverse list, and as we discussed, our base case would be if head is equal to null or head dot next equal to null. We're gonna simply return the head, and we're gonna use 2.2 variables. First one would be the current, which will point to head, and the next pointer will point to current dot next, and we're gonna have a while loop, and we're gonna check if next is not equal to null. We're gonna keep going till next is not equal to null, and the first and when we are at the head node, we're gonna update the head dot next as null. So we're going to check if current equal to head. We're gonna mark current dot next equal to null, and we're going to have to save the next reference of the next node into another variable. Let's call it temp, and once we have this, we can update the next pointer of next node equal to current, and once we do this, we can update the current node as next and next as temp, so that we can move on to the next iteration, and at the end we can just return the current node. So yeah, let's try to run this, and yeah, that's good, that works, and let's submit. Yeah, that's good, we're done. Now let's look into our second approach. So this second approach makes use of dummy nodes. So using dummy nodes is really common in linked list problems, and it helps us to avoid null pointer exceptions, and it also helps us to reach the head node from some point. So this will make sense as we solve more linked list problems using this dummy nodes. So here in this problem, the only use of dummy nodes is to avoid null pointers. So here we're going to use the same logic from approach 1. So initially we are going to have our current pointer point to our dummy node, and next would be the node 1. So also using dummy node, it helps us to deal with the case when there's only one linked list element. We can cover that in our code itself rather than having it as a separate base case. So that is what helps us with using dummy nodes. So we are going to have temp.22. So, and we, as you know, we update the next to current, and in the next iteration the node 1 will be current node, node 2 will be the next node, node 3 will be the temp node. And as we go through the while loop, we are going to have a situation like this, and at the end, as you can see, the head node points to the dummy node, the head.next points to the dummy node, and we're going to have to update the head.next as null, and at the end we can just return the current pointer and we'll be done. In the second approach, like most of the while loop is going to remain the same. For example, this part is going to remain the same. So let's understand by creating a dummy node first, and then it will be easier. So I'm going to just simply update this code. So I'm going to create a dummy node, new list node -1, and dummy.next is going to point to the head node. So in this case, the current will start from dummy node, and the next one will be the current.next. So here the base case, for base case we're only going to need the head equal to null check, as we're going to as in the code we're going to cover for linked list elements greater than equal to 1, so we don't need this check. And as we are processing the linked list, so we don't need this if block now. So as we are going through the linked list, so it's going to reverse the linked list, and at the end we only have to update the head.next as null, and we'll be done. Let's try to run it. Alright, accepted, submit, and yeah, we are done. So now let's have a look at the approach 3. So here we have our linked list. So in this approach, what we're going to do is we're going to directly work with null pointers. So here initially we're going to use a current pointer, which starts with pointing to the head node, and we have another variable previous which points to null, and as we iterate over the list, we're going to need to save the next element, that is current.next, into another variable. Let's call it next. So here as we iterate over the linked list in our while loop, so the while condition here, it would be while current is not equal to null, and inside our while loop what we're going to do is we're going to update the current.next pointer to be pointing to the previous, and after we do that, we're going to have to update the previous to current, and our current would become our next, and here we first need to update the previous pointer before we update the current pointer. This is because if we update the current pointer before previous, then it would lead to previous being updated incorrectly. And inside of our while loop, So the code would be, so first we have to set next as current.next to avoid losing the reference to the next node, and then we're going to do is current.next equal to previous, and previous is equal to current, and current would be equal to next. So now let's have a look at the next iteration. So here after the first iteration we have this situation. So here our node 1, it's set to null node, and now we are going to set the next pointer of our current node to point to previous. So we're going to update this to this, and we already saved our next pointer, and we move on to our next iteration. So for next iteration the situation would be something like this. Here we have previous would be current, current would be next, and the next one would be this. So here we're going to update this pointer to point to this, and as we keep going through the iteration we're going to have a situation like this. So here our current pointer would be, this would be our previous pointer, and our current would be null, and in the end as you can see the current node becomes null, and the previous pointer, this points to the head of our new reverse linked list. So at the end we just return the previous pointer, and the base case here would be when head is null, and all the other cases would be covered in the rest of the code. So here we have our function reverse list. So initially the base case is if head is equal to null, then we simply return head, and now we're going to need two pointers initially, the current pointer and the previous pointer. So initially we have our current pointing to head, and we have our previous as null, and in the while loop we're going to have while current is not equal to null. First we are going to save the next reference of our current node, because we're going to update it next after we're going to update it at line 21, and what we're going to set it as current.next as previous, and next we're going to update our previous to current, and current will point to next. So here line 22, like we need to first update previous node before we update the current one, because if we do this line if we do line 24 before line 23, then the previous would be set incorrectly, and once we are done we are going to return our previous, because previous pointer at the end would point to the head of our new reversed linked list. So let's try to run this, and it works, I think. Let's see. Yeah, it works perfect. Alright, so if you have any questions, let me know in the comments, and if you would like to see any other approaches, let me know. There are like a few more approaches to solve this question. So the three approaches we covered, they use of end time and constant space, O of one space, and like there is one approach which uses extra space using a stack, and also we can simply use recursion as well to solve this question, but those two approaches will use extra space and it won't be optimal. So yeah, thanks for watching, and I'll see you in the next one.